This video is on Le Chatelier's principle. Le Chatelier's principle states that when a stressor is applied to a system at equilibrium, the system reacts in a way to relieve the stress. So if we think about a reaction at equilibrium, we can think about a seesaw. So if this is my seesaw, I have my reactants on the left and the products on the right. At equilibrium, my seesaw is balanced. If I were to increase my amount of reactants, that would make this side heavier. On a seesaw, when something is heavier, that side goes down, and it would look like this. My equilibrium, or my reaction, would like to get to equilibrium, so I would have to shift some of my reactants over to the products. So I'd have to do the reaction and shift them over until they then equaled again, and I reached equilibrium. So that would shift to the right. If I'm at equilibrium and I add a bunch of product in, so I add something to my reaction that increases my amount of product, that's going to make this side of my seesaw heavy, and I'm going to want to look like this. Here, I'm going to have to go in reverse and shift to the left, going backwards, creating more reactant. So I shift to the left until they're equal again, and I return to my equilibrium. So again, reactants on the left, products on the right. I have this double arrow, so it can look like an arrow like this, or I can do two half arrows, which would look like that. If I shift to the right, right is towards products, I'm going to increase my products. I'm going to decrease my reactants. So I'm shifting to the right, that uses up reactants, makes more product. If I shift to the left, that decreases my products, right? So I get rid of an excess of products, and I make more reactants. So I decrease products and make reactants. So in a given reaction, I can do different stressors. My stressors include adding chemicals, removing chemicals, increasing temperature, decreasing temperature. I can increase the volume of my container. I can decrease the volume of my container, or I can add a catalyst. If I were to add a chemical, just like we said before, if I'm adding a chemical, so like adding something over here that makes that side of my seesaw heavy, I need to use up what I've made, and I'm going to shift it to the other side. So it means if I've added a chemical, it makes that side heavy, so I'm going to use that up. So I shift away from my added chemical. Conversely, if I remove a chemical, so in this case, if I remove this and make it go away, that makes my right side heavy, so it would fall down, nothing here, and again, I'd shift to make more, so that way my seesaw balanced out. So when I remove a chemical, I shift towards the chemical that I removed to fill in that hole. Some of our reactions will have temperature or heat listed. If I increase temperature, just like before increasing a chemical, I'm going to shift away from what I've added. But if I decrease temperature, I'm going to shift toward. And we'll see the word heat listed in the problem. If I increase or decrease volume, this only works for gases, so I need to have the little G after my symbol. So I have a symbol and a little G after it. That tells me I have a gas. If I increase the volume, I'm going to move to the side with more gas molecules, and we find that by looking at the coefficients. And then if I decrease the volume, I'm going to go to the side with less gas molecules, and again I look at my coefficients on my equation. If I add a catalyst is only going to decrease my rate of reaction. It's not going to affect my products or reactants, as we've talked about. So there's no shift in my reaction. It just makes the forward and reverse reaction happen faster. So let's go through an example here. Here I have nitrogen plus hydrogen makes ammonia and heat. So it gives off heat, so we say this is an exothermic reaction. Because heat is given off. If I were to add hydrogen is on the left, so if I have my little seesaw, If I'm adding to the left, means I'm adding a whole bunch of stuff on the left. I'm adding hydrogen. That means my seesaw is going to fall down on the left, right? Because my left side is heavy. So to get rid of what I've added to the left, I need to shift my seesaw to the right, or shift my reaction to the right. So it shifts to the right. When I shift to the right, I go towards my products. So remember, this side of my reaction are your products. The left side of my reaction are the reactants. So if I'm shifting to the right, I'm shifting toward my products, so their concentration is going to increase. And I'm shifting away from my reactants, so their concentration is going to decrease. So going away from them to even this back out, I need to decrease my amount on the left, increase my amount on the right, so that way it hangs out at my equilibrium balance here. So I added stuff to the left, my hydrogen to the left, that made this ball really big. And I needed to shift more to the right to balance it out. If I'm at equilibrium and I go ahead and I remove nitrogen, so instead of having equal balls on both sides, right, nitrogen's here. If I remove that, that makes a big hole on my left side of my equation because this goes away. When that goes away, that makes my reaction shift and change where I have a whole bunch of products. So my reaction is going to want to fill that hole. And to fill that hole, I'm going to shift to the left to take my products and turn them back into my nitrogen. So I shift to the left. When I shift to the left, I shift away from my products, so their amount's going to decrease in order to make more of my reactants, so that's going to increase. If I increase the temperature, we said that increasing the temperature, if I increase temperature, I go away from the heat in my reaction. In my reaction, my heat is here, so if I increase the temperature, I'm going to go away from the heat. So temperature increases, so it's adding to this side of my equation, so it makes my seesaw go down. I need to shift over to balance my seesaw back out. So I shift to the left. When I shift to the left, that's going to decrease my products made because I'm shifting away from them. It's going to increase the reactants made because I'm shifting towards them. Then if I increase my volume, we said increasing the volume means I make a bigger container. It's going to go towards the side with more gas molecules. On my left side, I have 1 gas molecule with my nitrogen and 3 with my hydrogen. So in total, that gives me 4 gas molecules on the left and only 2 gas molecules on the right. So an increased volume goes to the side with more because they want to spread out. In this case, it's going to go to the left. That means going to the left, I'm going to decrease my products and increase my reactants. Finally, if I add a catalyst, that's going to make my forward and reverse reaction happen faster. So that adding a catalyst provides no shift in our reaction. So there is no shift here, which means that my products stay the same and my reactants stay the same.